Okay. Overview of nephron function. When you look at the main structures of the kidney, it consists of the renal corpuscle, comprised primarily of the glomerular, or what's called Bowman's capsule. The glomerulus is the blood supply feeding into that capsule. You then have the proximal convoluted tubule. This portion is closer to the nephron, or to the capsule. It's convoluted, so it's called the proximal convoluted tubule. Distal convoluted tubule, and the collecting duct. This portion is referred to as the loop of Henle. Sometimes referred to as the nephron loop. So when you look at urine formation, you're looking at urine or plasma being filtered from the blood supply to the Bowman's capsule, and to the, fluid being transferred from the glomerulus into the Bowman's capsule. That filtrate travels to the proximal convoluted tubule, loop of Henle, distal convoluted tubule, and then out the collecting duct of urine. When we look at urine formation, it's comprised of three main parts to form urine. First is filtration. Second is reabsorption. Third is secretion. Filtration occurs in the Bowman's capsule, involving the glomerulus and the renal corpuscle. The whole thing here is called the renal corpuscle. Reabsorption occurs in the proximal convoluted tubule, and secretion occurs in the distal convoluted tubule. And here's the significance of urine formation. Filtration itself is very effective, in that the kidney, a healthy kidney, will filtrate and form about 180 liters of urine a day. Now, if you urinated 180 liters of urine a day, how long would you live? About 3 minutes. So you have to recover that water. You can't lose that much water. Reabsorption in the proximal convoluted tubule is where reabsorption begins. In fact, about 70% of the water that is recovered in the proximal convoluted tubule. About 20%, 20% is recovered through the loop of Henle. Recovery means it goes back into the blood supply. And about 9% is recovered in the distal convoluted tubule. That adds up to be 99%. Between 1% remains not recovered. That's why we urinate. The 1% is about 1.5 liters a day normally. A little more for men, a little less women. So we'll discuss filtration and the control of filtration, with reabsorption, the role of secretion, maintain this vital 1%. And we'll look at the loop of Henle involved here also. Now, what's unique about this, let's say the distal convoluted tubule only recovers 8%. that means you'll have 2% left. So you're going to have only a 1% change in excretion rate, right? But a 1% change causes what to happen to the volume? It'll double the volume that you urinate. Thus, if one needs to maintain or control the urine output, which equates to water volume, which equates to total blood volume, it takes very small changes here to make very large changes in urine output. Okay, do you understand the overview then of the nephron and how it works? When we come back from break, we'll look at the renal corpuscle, proximal tubule, loop Finley, distal. So a quick summary, blood flow comes in to the glomerulus. This is a capillary bed, very large capillary bed. It's about 400 times more permeable than most capillary beds. So you lose everything, pretty much, not everything, you lose everything but large proteins into the Bowman's capsule here. The plasma here is the same as the plasma here, same electrolytes, sodium concentration. The only thing this does not have is red blood cells and large proteins, otherwise it's the same as plasma. This blood vessel follows along here, so it absorbs 70% of the water. Goes through here as the vasa recta, which absorbs 20% of the water, and goes back to here, where it absorbs the final 8% of the water.
When it goes into the Bowman's capsule, it's losing the plasma. Is that what you said?
Yes, by filtration. We discussed filtration as passive transport. Hydrostatic pressure forces the fluid out into the Bowman's capsule. So we'll look at the filtration process in detail in just a little bit. Okay, any other questions in regard to the overview of the renal function?